Welcome to Heavens Declare. I'm Jim Burr, and today we are talking about the solar system. We left off last program talking about our Earth and the planets, and we're going to continue on with that. But the heavens declare, yes, they sure do declare the glory of God, don't they? We see the beautiful. This Hubble is just fantastic. What the Hubble has shown us that we've never seen before, and so our first graphic is going to be of Saturn. You know, the rings of Saturn are incredibly beautiful. Can you imagine waking up in the morning and seeing a sunrise? These rings would go up 50,000 miles. Can you imagine a sunrise rippling through rings for 50,000 miles, or a sunset rippling through space? I'd like to show you that picture now, that graphic now, of the beautiful picture of Saturn. And this is one from the Hubble Space Telescope. Those rings about 170,000 miles across. Saturn about 1 billion miles away from us in space. So we have our solar system: Mercury, Venus, Earth, Mars, Jupiter, and then Saturn comes next with the rings. But we've discovered that there are rings around God apparently likes rings. Spacecraft has now discovered rings around our sun, with spacecraft rings around Jupiter, Saturn, Uranus, Neptune, and rings around Betelgeuse, that star. It's a shoulder star in Orion. As you look at Orion, it would be up in his his upper shoulder. And satellite now, they've discovered Betelgeuse has rings around. It is like one of the biggest stars we know about. In fact, we're going to show you an image of Betelgeuse in a little bit. It's like 1 billion miles in diameter. If we put Betelgeuse where our sun is, Mercury, Venus, Earth, we'd all be going around inside that star. So would Mars, the asteroid belt. So would Jupiter be inside the star Betelgeuse. And now they've discovered, and I don't have a picture of it, I can't show you the picture, but they tell us they've discovered there are rings around Betelgeuse. And the rings around Betelgeuse are so big, they say that if you were going to drive across here with your automobile at the rate of 1,000 miles every day, it'd take you like 40 million years to drive across the rings of Betelgeuse. They're about a light year across, actually. And so we want to talk a little bit about the sun, because how did the sun form? All this energy from the sun. We've got a clip coming up showing some eruptions on the sun. And it's just amazing to see the eruptions on the sun. We got eruptions going out. Well, this telescope behind me actually is a solar scope for looking at the sun. Now, you don't want to look at the sun because you go blind, okay? Galileo, in fact, did go blind looking at the sun. And he sat in a closet in the dark for a couple of weeks thinking that his eyesight could be restored, but it never really changed. So you don't ever want to look at the sun unless you got a special instrument, and that is a special, I've had this for a solar scope for about 30 years, and we look most every day at the sun. I've seen eruptions coming off the sun to reach to the moon, 250,000 miles, these eruptions. They typically don't stay around too long, but a true flare is gone in 15 minutes. And in fact, sometimes we'll look at the sun and we'll see the sun's here, okay, we see a puff of cloud above the sun, and I didn't see the flare go up, but the flare shoots up 400 miles a second, and then it'll sometimes leave a cloud. The flare has disappeared. You don't see the connection, but you see this cloud, which will dissipate over a couple of hours. So I'd like to show you that roll now of the eruption on the sun, and tremendous eruptions on the sun. Plasma going up there, and we're fortunate that an eruption like this was not headed our way, but headed off to the side of the sun rather than headed directly at us, because these eruptions headed our way could cause serious problems on Earth. Back in the 1800s, we had a solar flare that actually melted down telegraph lines. In 1986, I think it was, in Quebec, a solar flare melted power grid down. And we haven't had any really big ones headed our way. There was one headed to Mars here a while back. And in other words, if it's coming straight off the surface, the sun is headed our way. If it comes off on the sides, it doesn't hit us with the intensity. And of course, that's what causes the northern lights. Charged particles from the sun ionizing the hydrogen atoms in the upper atmosphere causes beautiful northern lights. I was raised in Minnesota, where we're quite familiar with northern lights. In fact, I've been to Alaska a couple times, and flying on night to Alaska, you'll see the northern lights. But these eruptions on the sun are just incredible. And if they, we have today so much electronics, so much spacecraft, your GPSs, your satellites. If we get one coming our way straight at us, a big solar flare, we could have some serious issues. But let's get back to where did this all come from? Evolution says in the beginning, the universe, like this one book I have, Dr. Picani says, that the universe began with a dot as small as a millionth of a millionth the size of the smallest atom. Well, that's pretty small. And he says the temperature was like a million degrees. And this is how you could rationalize a universe without a creator, I guess. Because he goes on to say there's this tremendous energy. You saw the eruptions. 120,000 sextillion tons of matter blasting off the sun. Where did that come from? From a little dot smaller than an atom? But here's how your logic works. He said, well, there's this tremendous energy in the universe. They're coming from all the stars, but there's also tremendous negative gravitational potential energy. So we got positive energy and negative energy which cancel each other. And therefore, the universe could create itself. And Stephen Hawking would say the same thing. Stephen Hawking says, yes, the universe can create itself. The Bible says, in the beginning, by the word of the Lord were the heavens made. In the beginning, God created the heavens and the earth, 100 billion stars. And how did the sun form? It's a joke, folks. It is a joke how evolution says our sun came into being. And they would tell you, as I said, we have started with a little dot, and then all of a sudden we had all this hydrogen gas in the universe, trillions, maybe 12 trillion miles across, this hydrogen gas, and somehow gravity started pulling gas together. Well, check out Boyle's gas laws. We know that gas expands to fill its container. If I had a perfume bottle here and I sprayed it, it wouldn't be long and everybody in this building would smell it. You see, gas wants to expand to fill its container, but they say no gravity. Gravity of what? What gravity? Pull the gas together, and it started spinning and collapsing and spinning and collapsing and spinning and collapsing till gravity pulled this gas. Now remember, that space is 450 below zero. We have to get to 100 million degrees for the hydrogen atoms to fuse together to create the sun. To get the sun to start, we need 100, 200, 150 million degrees. In the coldest of space where it's 400 below zero, in a vacuum of space where gas would want to expand, they say, no, it was pulled together by gravity till gravity got it so hot, our sun ignited. Okay, that was the miracle. That's how the sun formed. And so it's a joke. I want to just read a statement from one of the science book. How did the first star appear? Well, it takes a star to make a star. You got to have a star before you can make a next star, right? Folks. Okay. Here's what they say. Scientists believe that the sun and the solar system were formed when a cloud of gas and dust in space was disturbed, maybe by the explosion of a nearby star. Well, I thought we were trying to figure out how the first star came, how our sun came, and how the first star came. But now they say, no, you got to have a star to make a star. And so maybe our sun formed by an explosion of a nearby star called a supernova. Where did that star come from? This explosion made waves in space, I suppose like a wave on a lake. The waves which usually you throw a rock in a lake, the waves go outward, but they say which made waves in space which squeezed squeeze the cloud of gas. Are you going to, in a vacuum, you're going to squeeze the gas together by waves? Squeeze the cloud of gas and dust. Squeezing made the cloud start to collapse as gravity pulled the gas and dust together, forming a solar nebula, okay? Now, you know, you watch an ice skater on the ice. What happens? They're skating and all of a sudden they stop spinning and they pull their arms in, right? They've clocked them at 308, the fastest ice skater, 308 RPM, revolutions a minute, 308 times a minute. If you took 12 trillion miles of gas and you pull it together with gravity and it was spinning and condensing and spinning and condensing, the more it pulled itself together, the faster it's going to go. You know, the ice skaters, the more they pull their arms and legs together, the faster they go. That'd be a law of physics. So what would you expect if you looked at the sun? You would expect the sun to be screaming, right? Like the blades on a jet. Folks, you can't even see the sun move. I watched the sun through that telescope over there, the special scope. It's a very special scope. Don't look at the sun unless you have a special scope. But for the last 20, 30 years, I look at the sun almost every day, and you can't even see it move. I watch sunspots. They always appear on the right. And they're here today, next day. So a day goes by, the Earth spins, what? They move that far. Next day, next day, next day, next. It takes 14 days for the sunspots to move across the sun. It takes 28 days for the sun to spin. But if this theory, this idea, this joke of how the sun formed, it's a joke, folks. It is a joke. They don't know how it formed. The sun should be just screaming around, but it actually, you'd have to drive a stake. You can't even see it move. You'd have to drive a stake in the ground over 28 days to see it turn. The Earth is turning 28 times faster. And this is called the law of conservation of angular momentum. If this collapsed and it was spinning, all the planets should be going the same way. All the moons should be going the same place. We have moons spinning the wrong, planets spinning the wrong way. Venus, Pluto, it's actually Uranus, I think, that's spinning on its edge, spinning the wrong way. And evolution says, well, you know, maybe something smashed into caused it to go the wrong way. I think 20-some of the moons in the solar system are spinning the wrong way. So there's just so many problems with evolution and the Big Bang, folks. I mean, excuse me, but it is a joke. It is an absolute joke. So we have, in the previous session, we actually showed you a picture of our sun, Mercury, Venus, Earth, Mars, Uranus, and Neptune. But we didn't show you, now the sun, you know, I mean, we could put 1 million Earths inside the sun. Okay, 1 million Earths would fit inside the sun. But we didn't show you how our sun compares. You know, our sun is just kind of an average star. Nothing special about our sun, just kind of a everyday, ho-hum, average star. There's many stars that are bigger than our sun, many stars that are smaller than our sun. And so we want to show some of the bigger ones. I told you a minute ago about Betelgeuse. That's 1 billion miles in diameter. So we have another graphic coming up which will compare our sun with Arcturus. So here we see Arcturus, much larger than our sun. And you see the Earth is gone, Jupiter, Saturn, Uranus, they're all gone on the screen. I mean, Jupiter would be the size of 1 pixel. So here you see our sun, so small compared to Arcturus. Arcturus is talked about in the Bible, and we're going to get to that in one of these programs, because Arcturus is a runaway star, and God asked Job, can you guide Arcturus? You see also Pollux there. That's a Castor and Pollux in the constellation of Gemini. Those are that's a winter star. And then Sirius, which is also in the sky in the wintertime, is just east of Orion. And so that's kind of interesting. But is Arcturus the biggest star? No, we've got stars bigger. We've got another graphic coming up showing bigger stars. Betelgeuse in this screen is and Antares. And So Betelgeuse, the one as I mentioned, was 1 billion miles in diameter. When you look at this graphic, you don't even see our sun. Our sun has disappeared because it's so small compared to these larger stars. And now Arcturus is dwarfed by Rigel, Aldebaran, and Betelgeuse and Antares. These are all stars you can go out and see in the sky. Rigel is in the constellation of Orion. It's his lower, if you look at Orion, it'll be on the lower right-hand side as you see it. Aldebaran, that's in the constellation of Taurus the Bull, which is just to the west of Orion. And Betelgeuse is in Orion. And Antares is a summer star, very low in the sky. It is quite a red star. And I understand that Antares in Latin means not Mars. It turns out that people were often confusing Antares with Mars because the color was similar. Antares is quite reddish, and it's low in the sky, and in the south actually for us in the northern hemisphere, and sometimes not too far from the orbit where Mars would go. Now we want to go to the biggest star we know about and compare it to our sun. The biggest star we know about is Canis Majoris, and it is like 1.8 billion miles in diameter. You'll see that our sun is just really dwarfed, really, really small compared to Canis Majoris. And the sun down there on the left and a little piece of the slice of Canis Majoris. And often people, when they sit through these programs, say, you know, I feel so small. Why would God be interested in me, you know? And we're told in Desire of Ages that the Lord is disappointed when people place a low estimate upon themselves. You know why? Because He desires His chosen heritage to value themselves according to the price He has placed upon them, the unspeakable gift. Christ, who left the glories of heaven, the holiness of heaven, the beauties of heaven, the worship of the angels, came down here and didn't even have a pillow. Did you have a pillow last night? You know, He gave up all of that. The Bible says He considered a heaven a place not to be desired while you and I were lost. And so the Lord is disappointed. Don't place a low estimate upon yourself. The Lord is disappointed when His people place a low estimate upon themselves. He desires you, His chosen heritage, to value themselves according to the price He's placed upon you. Yes, thanks be to God for the unspeakable gift. We have another graphic coming up of a cluster of stars in our Milky Way galaxy. In our galaxy we have, you know, 100 billion stars. Okay, and these stars are just all going around, kind of like the solar system, 100 billion stars. But when we look in our galaxy, we see various things. We see constellations. Now, a constellation would be a group of stars you could make a stick figure about. You could draw a stick figure like Orion or the Big Dipper and Hercules, some of these things. So when we say a constellation, we're talking about just a group of stars that we see from Earth, and you could make an image of. We have 88 constellations. And so a galaxy would be a conglomeration of 100 billion, 200 billion stars. A constellation would be a group of stars. And then we also have these clusters. We have open clusters, which have hundreds of stars in them. These are blazing suns. You know, our sun's just the average star. So we would see open clusters like the Pleiades, the seven sisters. We see 7, there's 500 there. We have the double cluster, which is like 2-star clusters, beautiful cluster right up near Cassiopeia in the sky. And then we have these globs of stars. They call them globular clusters. And there'd be millions of stars. The Omega star cluster is, they believe, about 10 million stars. And that is the biggest star cluster that we know about. We don't know about the ones we don't know about. But the Hubble has zoomed in on the Omega star cluster. And it just filled with the most beautiful colors. Stars of the most beautiful colors, and the Hubble zoomed in on that. We're going to show you a video clip in another series of how these stars will move over the next 10,000 years. But in Genesis 22:17, it says, as the host of heaven cannot be numbered, nor the sands of the sea measured, so will I multiply the descendants of David, my servant. From the stars, this is a quotation from, I think, Steps to Christ. From the stars that in their trackless course through space follow from age to age their appointed path, down to the minutest atom, the things of nature obey the Creator's will. Not all the wisdom or skill of man can produce life in the smallest object of nature. It is only through the life which God Himself has imparted that either plant or animal can live. And it's interesting because during the French Revolution, you know, they persecuted the Christians, they killed the Christians, they did everything they could. And the statement was made by the authorities: we are going to burn your Bibles, we're going to tear down your churches, we're going to destroy everything that reminds you of God. And the people responded, but you will leave us the stars. Okay. So when we were talking about the galaxy, the Milky Way galaxy, and they believe there are as many galaxies as there are stars in our Milky Way galaxy. And they think, depending on which book you read, some books we've been saying for a long time, 100 billion. If you were in fact going to count 100 billion at one every second, it would take you about 3,000 years just to count them. But other books you read say, well, maybe maybe there are 200 billion, maybe there are 300 billion. Depends on which book you read. And the counting the stars are kind of a ballpark guess. It really, you look in the center of a galaxy, and you'll see just a maze of light. We can't see the individual stars in the core of the galaxy, in the heart of the galaxy. And yet we know they're separated by trillions of miles. So the point I was making, when it comes to counting the stars, it's a ballpark guess. It's anybody's guess. They can count stars in the outer part of the arms where they can resolve individual stars, but to look at the core of a star. So, I think because they vary so much from book to book that you read 100 billion, 200 billion, 300 billion stars. Now, when it comes to measuring the stars, the distances, this is very interesting. People often ask, well, how do we know the distances? It's my belief that they are 100 times better at measuring distances than they are at counting stars. And so how do we measure distances? Well, we have some good ways of measuring distances. And let's say this table is the sun. And we know the Earth goes around the sun, and so that we know that a certain time of the year the Earth is going to be over here on this side of the sun, my right, and then 6 months later the Earth's going to be over here. That's a 186 million mile baseline. 93 million miles to the sun here. 6 months later the sun's over there, 93 million miles. Well, so when I'm over here, I can look at this camera, and I have a baseline, 186 million miles, and I have an angle. We can triangulate, and then 6 months later we'll be on that side of the sun, and we can get a triangulation and measure the distance. Now there comes a point where that 186 million miles does not really shift the angle. There's a point in which we reach where we can't really measure that angle because it doesn't move that much. But the stars behind, we can measure this star, but the one behind actually will shift. And so we can get a measurement there. And so that's how we would measure the closer stars. Now, it turns out to be, God has put some amazing candles out there, okay? They're called Cepheid variable stars. There are stars that are like a light bulb dimmer, and they would go like from 5 watts to 100 watts, or 10 watts to 50 watts. These stars get dim and bright, and lo and behold, we look at our watch, and we go, wow, this thing varies. It gets light and dim. It takes 10 hours, 31 minutes, and 21 seconds. Every 10 hours, 31 minutes, 21 seconds, it goes from a 5-watt light bulb to a 50-watt light bulb. And so as we look around, we see all these Cepheid variable stars that change in brightness with time. They're all locked in time, and we can measure the distance. We can measure these stars because they're in that realm where we can measure distance to stars, and they can measure the brightness of a star like you can't believe. The sensitivity of these machines, instruments, and cameras, I can't believe it. I can tell you some stories about my experience with that. But so they can really measure very accurately the brightness of these stars, and lo and behold, those that take 10 hours, 31 minutes, let's say they're the 5 to 50 watt light bulbs, okay, or stars. And they look over here, and here's a 10 that goes from 10 to 30. Here's a go, you know, and so the brightness varies with time. And lo and behold, we look at another galaxy. We look over at Andromeda Galaxy, which we think is 2.8 million light years away. And lo and behold, we look at our watch and we go, whoa, they got Cepheid variables in Andromeda Galaxy, you know, 10 hours, 31 minutes. And so this allows us to measure distance. We know that the brightness diminishes with the square of the distance. Every time you double the distance, it's 4 times dimmer. And so we have really good ways of measuring you know, stars in distant galaxies using that principle, looking for Cepheid variable stars. Now, beyond that, we get to a point where the galaxies are so far away, we don't see the individual stars, and those, you know, are we can't actually measure using the Cepheid variable stars the distances to those galaxies, and for that they go to redshift. And we know that light actually shifts when it's moving away from us. It shifts towards the red. Light moving towards us shifts towards the blue. We can look at galaxies, and galaxies are spinning. And on one side of the galaxy we see stars shifting to the red, and on the other side the stars shifting to the blue. In fact, we can show you the Butterfly Nebula coming up here in one of these programs. And it's a nebula which they believe is spinning. It was photographed with the Subaru telescope in Hawaii. And on this Butterfly Nebula, it looks like a butterfly wing. On one side you see the stars all shifted towards the magenta, on the other side shifted towards the blue. So when they tell you that there, you know, are so many stars in a galaxy, I don't think we have a really good feel for the accuracy of the numbers of stars. But when they talk about the distances, I think they do pretty well. You know, in what we have ability to measure the stars. And that's one of the questions, you know, that always comes up when we're lecturing is how do we know the distances out there, really that far away? And we're going to be showing you coming up a galaxy that they say is 13 billion light years away. And from that we can go to Psalm, you know, 103, where it says the high as the heavens are above the earth. That's how great God's mercy is towards us. Well, folks, we're coming to the end of our program. I want to thank you for watching. Join us again next time for Heavens Declare. Thank you.